What's up, guys? This is our second video for today. This is day 15. You should have already watched the density pre-lab and completed the pre-lab assignment. So then I have this quick video that we'll watch on unit 2. So we are starting unit 2, and the density is kind of like a end of unit 1 kind of thing. It's a little bit of both. So it's covered in a little bit of both units. But unit 2 is on properties of matter and change. So here's some things that we'll see in unit 2. We're going to look at physical versus chemical changes today. That's pretty easy. And then we'll talk about intensive versus extensive variables, or intensive versus extensive properties. We'll look at the types of matter. So what are the types of matter around you? How do we classify matter? And what is density? Okay, so this is unit 2. You guys probably already know some of this stuff, so you probably know, have an idea of what a chemical change is. And if you see something, you want to be able to say, okay, is that a physical or a chemical change? Did I change it into something else, or is it still the same thing? All right, so we should be able to do that. We'll talk about these. Remember that density is an intensive property, which means that it does not depend on the amount of substance. Extensive values do. Okay. Types of matter. You guys probably have an idea of what the types of matter are there. There are these things called elements, right? There are mixtures. There's something else called compounds. So we'll be able to tell the difference between them. There's pure substances. All right, and so we'll be able to classify things as a pure substance or a mixture. We'll be able to classify elements versus compounds, and then we'll have to classify matter. So if we say, okay, here's matter. Let's make our like a chart where, all right, we got this one, then this one, and then we break down into this one and this one. And how does it break down? How do we break down matter and classify it into its groups? And then we got density, which, remember, density is mass over volume, because we love density, right? All right, vocabulary. So matter is anything composed of atoms. So anything that's made out of stuff. So anything that's not energy. People, cars, food, metals, water, air. It's all matter because it's made out of atoms. Okay, it's made out of stuff. Mass. Mass is a measure of how much matter is in an object. Okay, so you're going to use a balance or a scale to measure mass, and it's measured in grams, little g. Example, how many grams are in something? How many kilograms or something? Okay, what's the mass of something? Is mass the same on Earth and the moon? It is. Okay, so you would weigh the same, and you would have the same mass. But you would weigh different, because weight is the amount of gravity on you. Okay, but mass would not change. Mass is how many atoms you were made out of. Okay. Weight is a measure of gravity or pull of matter on a scale. So it's the weight. It's the measure of gravity's pull. So you would have a different weight if you went to the moon, and you'd be able to jump higher, which is cool. Volume. Volume is how much space something is taken up. So 15 milliliters. Take a graduated cylinder and fill it up with 15 milliliters of water, and that's the volume that it takes up. 2 liters of Dr. Pepper, right? Or 500 cubic centimeters. All right, here are 2 measurable properties. Extensive properties depend on how much matter you have, and intensive properties do not depend on how much you have. So we'll be talking about those later. Okay. Remember that density is an intensive property. Okay. Physical and chemical properties. Physical property can be observed without a chemical change occurring. Examples. My desk is brown. So if I look at my desk, I see that it's brown. I am not going to chemically change my desk into something else in order to see that it's brown. So that's a physical property. The walls are white. If I look at the walls, they're white. I don't need to do anything to the walls to see that. Water is a liquid. So anything that you can see without having to change the substance into something else, it's called a physical property. So that can include color, size, mass, volume, state. Is it a liquid or a solid? All right, now chemical properties can only be observed when a chemical change happens. So a chemical property would be how flammable something is, right? So if you take something and burn it, how easily does it burn? So when paper burns, plants experience photosynthesis. So that's a chemical process, right? So that's a chemical property. We know that plants can do that. And then an old car rust. Rusting is actually a chemical reaction where a metal is turning into kind of a brown, powdery substance, and it's chemically changing into something else. So if it chemically changes into something else, we call it a chemical property. A physical change is where the atoms are not rearranging into new substances. Physical changes include all changes of the state of matter. So if you go from a solid to liquid to gas, like boiling, melting, evaporating, freezing, all those things, those are physical changes because it's still water. If I take water and boil it, okay, and then collect that gas in a tube or connect it in a bottle of some kind, and then cool the bottle back down, I can get it back to liquid water. And then I can even freeze it. So it's still water. It just changed forms. It changed from solid to liquid to gas. So if you boil something or freeze something, you're changing the state of matter. It was a solid, now it's a gas or whatever. But it's still water. You're not turning it into something else. So it is not a chemical change. That's a physical change. And this is a very commonly missed concept. All right, so any kind of change of phase is a physical change. All right, physical changes also include changes in size, shape, and dissolving. So if I tear something, if I take a piece of paper and tear it in half, well, both of those halves of paper are still paper. It's a physical change. If I break something, smash it, okay? Or if I build something, put something together, if it doesn't change physically into something else, if it doesn't chemically change into something else, then it's a physical change. Now, another example of physical change is dissolving water. If I take salt and put it in water and mix it and it disappears and dissolves, I know that sounds and looks and seems like it should be a chemical change, but it's a physical change because all that's happening is the salt is mixing with the water. The salt is not turning into anything else. The salt is still salt after you're done mixing it in the water. You can taste it. You drink the salt water. It's going to taste gross. And then the water is still water. You didn't chemically turn the water into anything else. So you're just mixing them. So when you make your coffee in the morning, mix your sugar with your coffee. It's dissolving and mixing. It's a physical change. That's another very commonly missed one. Chemical. So chemical changes are where bonds are broken between atoms and new substances are formed. Okay. Chemical changes are going to be more interesting than physical changes because it's going to turn into something else. Okay, so you're going to have a chemical reaction. All right, so what are some types of chemical reactions, types of chemical changes? Burning something. Anytime something is burned, you're chemically changing it. Rusting, a rusty nail, right? The metal is breaking down chemically into something else. Decaying, so when organisms kind of break down stuff and cause stuff to rot, that's a chemical change. Or digestion, if you eat something, your food, your stomach acid has got your stomach's got acid in it, and so that acid is going to eat your food and it's going to chemically break it down. So that's chemical. Also, if you cook something, like if you bake a cake, that's going to be a chemical change. All right, there are 4 indicators of a chemical change. If you have heat or energy that's produced or a change in temperature, then that's going to be a chemical change. If the heat or energy of it is changing, then you are having a chemical reaction. So if it gets hot or gives off heat, we call it exothermic. And then if it takes in heat or gets cold, then that's endothermic. And those are both indicators of chemical change, if it gets hot or gets cold. If you produce gases or bubbles in the mixture, right? If you mix 2 things and you see bubbles form, well, then you're making bubbles. Those bubbles is a gas that wasn't previously there, and that gas is escaping. So you're making a new substance. Or if you make a precipitate is a cloudy solid. So this is actually 2 colorless liquids that when mixed are going to form a yellow solid. So this is probably lead iodide. And it looks cloudy, but actually what's going on is it's making a solid, right? And so if you see a color change or a cloudy look like this, this is a chemical change. So a precipitate is going to be a chemical change. If you create, let's see, a color change, if you mix two things and the colors of everything changes, well, then you're making a new substance. If you burn paper, if the paper was white, now it's all black and burnt, that's a chemical change. Iron rusting, you started with a silver nail, and now it's this reddish brown powdery stuff, then that's a chemical change. Another chemical change that I had on top of my mind is a change in smell. So if you smell a new substance, so if you mix two chemicals and then you have a smell, you're making a new substance. And if you're doing that, and if you're not careful, it could be something dangerous. So if you mix two chemicals and you smell something bad, probably should get some ventilation, go outside or something. You shouldn't be smelling some new gas that you're forming, right? Could be ammonia, could be chlorine gas. So we'll do these in class, okay? We'll look at these physical or chemical changes. All right, and then we'll type the answer in the chat of the mic. All right, guys, that's it. Thank you.